Hello, my dear students. How are you all? Hope you are fine and doing well. So, today we are going to start a very good topic, that's chemical kinetics, chemistry. So, I welcome you all to this amazing platform, that's Chemistry Wallah. So, we'll be uploading so many lectures of chemistry here, particularly the physical chemistry, so that can benefit the students of the class 12th, class 11th, and those who are the aspirants of NEET exam, JEE exam, and so many other examinations which are happening at the level of the 10+2. So I welcome you all to this platform once again, and I would also like to make humble request to all of you, if you like these lectures here, if you get benefited from these lectures, so please subscribe to this YouTube channel. This is your own channel, so we'll be uploading so many good lectures here regarding the chemistry. So once again I welcome you all here. So this is the very first lecture on this YouTube channel. So I'm going to start with the chemical kinetics. So chemical kinetics is a very interesting topic. It's very important for your board exams. It's very important for your NEET exam. It's also important for the IIT JEE exams. So and before actually I will start, I would like to make a humble request that if you are new here on this channel, so please consider subscribing to this channel. If you get benefited from this channel, so also share it with your other friends who are in your class, so they can also get benefited with these lectures. So please subscribe to this YouTube channel and also press the bell icon so that you can get the latest notifications of the lectures that will be uploaded on this website. So I would like to thank you for your cooperation in this regard. So now let's get straight to the topic, that's the chemical kinetics. So let's start chemical kinetics. So what's chemical kinetics? The big question here is, what's chemical kinetics? So chemical kinetics is basically a branch of physical chemistry. So chemical kinetics is a branch of physical chemistry. Which deals with first, it deals with rate of reaction. We write in short form as ROR, that is rate of reaction. Second, it deals with factors affecting rate of reaction. And third, it will study the mechanism of the reaction. Of course, the mechanism in terms of the kinetics and all that. So we'll study it later. So when we go in more detail, so the first basic thing is rate of reaction. It's the basic thing that we're studying chemical kinetics. Very important. Then we study the factors affecting rate of reaction as ROR. Now there are so many factors which affect the rate of reaction, but the two important factors which affect the rate of reaction are, first is temperature, and then it's your concentration. Now when we talk about temperature, so you have the Arrhenius equation. So it's a very important equation as far as the effect of temperature on the rate of reaction or rate constant is concerned. So we study it separately. And then when you talk about concentration, so you have order of reaction. So order of reaction can be like, we can have first order reaction, we can have second order reaction, the order can be third, you can have fourth, even nth order reaction, and you can have a zero order reaction. So order can be like fractional also, it can be negative. So we'll study in detail. This is a very important thing as far as the chemical kinetics is concerned, that's the order of the reaction. So we'll study in detail in the coming lectures. So after this, we study like the rate law. You study rate law, or you call it as rate equation or rate law expression. Rate equation, very important. Then we study molecularity. Molecularity of the reaction is very important. Then finally we study the mechanism of reaction. Mechanism of reaction, like in terms of kinetics and all that. So These are the basic things that we'll try to study in this. Like the first basic thing is the rate of reaction. Then we have factors which affect this rate of reaction. What are the factors which affect? Of course, we have two important factors like temperature and concentration. So we will try to study these. And there are some other factors also which will affect the rate of reaction. Then we have mechanism of reaction. We have rate law expression or rate equation. We study molecularity. So these things we'll try to study. The most important thing is the order of reaction. Whether reaction is first order, or second order, or third order, or zeroth order sometimes. So these things we'll try to cover in this topic. So now let's start. So today we will be only studying, we will study in this topic, today's lecture will only cover the rate of reaction. What is the rate of reaction? So let's start with the rate of reaction. I would request you, my dear students, to please take notes. I'm writing here, so you also try to write in your notebooks. It's better to make your own notes. It will be always helpful. When I was a maths student, I would always note things when our teacher would deliver the lecture in the class. So I would request you to please make the notes yourselves. So that's very helpful. So we'll now take rate of reaction. We write it in short form as ROR. So now what is rate of reaction? Like when you say something rate, so what do you actually mean by the term rate? Rate means change in the, like when something is changing with respect to time. So how this thing is changing with respect to time, that we basically called as rate. So rate of reaction is basically the change in the concentration of the reactants. So we define it as change in the concentration of reactant or product with respect to time. So how the reactant or the product is changing with respect to time, how its concentration is changing with respect to time, we basically call that as rate of the reaction. So आपका जो reactant है वो किस तरह से जो है चेंज हो रहा है, उसकी concentration कैसे चेंज हो रही है, आपका जो प्रोडक्ट है वो कैसे जो है उसकी concentration चेंज हो रही है, उसको हम कहते हैं rate of reaction with respect to time के respect में. तो आपकी for example I will try to explain. Let's suppose we have some reaction. Let's suppose we have a reaction A plus 2B. It gives some, let's suppose 2C. So now you will identify here we have two reactants, that's A and B. A, B, they are here reactants. Always on the left side we have reactants, and on the right side we have that's called as products. So C is here a product. C is the product of this reaction. So A and B, they are reactants. So now when A will, first you have A and B at initial, sometime at initial time zero, A and B, they are like maybe some moles, moles of A, moles of B. So after some time when the reaction will start, when these A and B will start reacting with each other, so the concentration of A and B will start decreasing, while the concentration of C will start increasing. So that's basically how this reaction, this concentration of the reactant change with respect to time, and how the concentration of the product will change with time. That's basically what we actually mean to say the rate of the reaction. That is very important. So A will start decreasing, again B will start decreasing, but C will start increasing. So this is the reactant concentration, reactants, and this is the product. Product concentration always start increasing, because products will form and reacts will start dissipating, so product will start appearing. That is how we actually define the rate of the reaction. It is very important. It is very important in the chemical kinetics. Very important. So keep this thing in your notes. Very important. So now we have different kind of reactions. For example, we have ionic reactions. So they are very fast reactions. So we have so many types of reactions. For example, the first we have is ionic reactions. Ionic reactions, they are very fast reactions. For example, we have like NaCl, then ionic reaction plus AgNO3. It will give you like AgCl is the white precipitate plus NaNO3. So this Na in your solution, you have already Na plus, Cl minus, you have Ag plus and NO3 minus. Now these ions are already present in the reaction, in the solution. So they will just have to combine with each other. Like this Na plus will go with NO3 minus and this Ag plus will go with Cl minus. So you get this product here, like AgCl. This reaction is very fast, it takes place in microseconds. So rate of reaction for this reaction, ROR, is not determined because it's not possible to determine the rate of reaction for such a reaction. Rate is very fast, it's a very fast reaction, like it takes place in microseconds. Then we have like very slow reactions, very slow reactions. In very slow reactions, like you have rusting of iron, or even for them not rusting. So it takes years to complete. Takes years to complete. You can see if you have something like some iron piece lying somewhere, so when it starts getting rust, so you can observe it takes a long time, very long time, even it can take years for the rusting to complete. So it takes years to complete. So rate of reaction, ROR, is practically not determined. So we don't determine the rate of reaction for such reactions, for example rusting of iron, because it is very slow reaction. It takes a very long time to complete. So then for which reactions we actually try to take the rate of reaction? So that is actually the main question here. So for which reactions we basically try to determine the rate of reaction? So we have reactions called as molecular reactions. We have molecular reactions which are moderate reactions. At the rate of reaction is moderate. So the other class we have is basically we have molecular reactions. Molecular reactions which are moderate rate. So we have moderate rate reactions. So in these reactions, rate ROR is neither too fast nor too slow. So they are moderate rate reactions. So your rate of reaction is neither too fast nor too slow. So for such reactions, we actually try to take the rate of reaction. For example, I will give you an example here. It's N2 plus 3H2. It gives 2NH3. A simple reaction. So here what will happen is like we have N triple bond N and we have H single bond H. And here it will form, and the product will be formed in this reaction, so it will be NH. So it will have N will have 3 bonds with H, hydrogen. So now here we have a triple bond, so these bonds will break. So this bond has to break for this product to be formed. And this bond will break. Now this bond will form actually because N has to form, then bond forms. So it takes time for the bonds to break here. Like earlier reaction, when you saw the ionic reaction, so you have just ions. The ions will combine with each other and they will form the products. Now here the bonds have to break because we have covalent bonds here. So these bonds will break, then this bond will form. So it will take some finite time. So from finite time will be taken in this reaction. This reaction will take some finite time. So the rate of reaction is practically determined. ROR is determined for such reactions. So इन reactions का जो rate है वो हम लेते हैं actually, क्योंकि यहाँ पे क्या आपका definite time लग रहा है, एक finite time लग रहा है, आपका यहाँ पे N2 है, नाइट्रोजन है, प्लस आपका हाइड्रोजन है और यहाँ पे आपका NH3 बन रहा है, अमोनिया गैस. तो यहाँ पे bonds break हो रहे हैं और यहाँ bonds form हो रहे हैं. तो इसमें finite time लग रहा है, definite time लग रहा है. तो इन reactions का जो rate है वो हम हमेशा से लेते हैं. तो अब हम आगे इसमें now next what we will see is we will try to study the mathematics of the rate of reaction. So ये तो हमने theory पढ़ ली mathematics की rate of reaction की, rate of reaction क्या होता है, इसका थ्योरेटिकल बैकग्राउंड क्या है, ये हमने इसमें ये सारा चीज़ पढ़ लिया। लेकिन जो आप रेट ऑफ रिएक्शन, जो आपको क्वेश्चंस आएंगे बोर्ड एग्जाम में या फिर आपकी जो इंट्रेंस एग्जाम्स में क्वेश्चन आएंगे, वो तो आपके उसके मैथमेटिक्स इसके ऊपर होंगे। तो हम इसका मैथमेटिक्स पढ़ेंगे, आर जो है इसका मैथमेटिक्स हम पढ़ेंगे, स्टडी मैथमेटिक्स, हाउ यू रिप्रेजेंट इट मैथमेटिकली। तो फॉर एग्जांपल हमारे पास अगर कोई रिएक्शन है, लेट्स सपोज वी हैव सम रिएक्शन अपनी 2a plus 3b, इट गिव्स यू 4c plus 3d, कुछ इस टाइप से हमारे रिएक्शन है। तो यहाँ पे हमारे जो रिएक्टेंट्स है वो हमारे, अब लेफ्ट साइड पे जो हमारे होते हैं वो हमारे रिएक्टेंट्स होते हैं, a और b जो है वो हमारे रिएक्टेंट्स हैं, और c और d जो है वो हमारे दे आर आवर प्रोडक्ट्स which we found in this section. So now what we will do is we will try to write the rate equation. Now this ROR is basically of two types. This ROR is of two types. So one is average rate of reaction, average rate of reaction. The second one is instantaneous rate of reaction. So दो तरह के होते हैं हमारे rate of reaction, average rate of reaction, instantaneous rate of reaction. तो जो average rate of reaction है पहले हम वो पढ़ेंगे। तो लेट्स सपोज हमें यहाँ पे रेट ऑफ रिएक्शन लिखना है, तो हम आर ओ आर कैसे लिखते हैं, आर ओ आर और वी कैन से एवरेज रेट ऑफ रिएक्शन। तो हम आप जैसे आप जो रिएक्टेंट्स होते हैं उनमें आपको -1 लिखना है, डिवाइड भी करना जो स्टोइकियोमेट्रिक कोएफिशिएंट, और यहाँ पे स्टोइकियोमेट्रिक कोएफिशिएंट है 2, और यहाँ पे हमें लिखना है चेंज डेल ए, दैट्स द चेंज द कंसंट्रेशन ऑफ ए डिवाइड बाय टाइम डेल्टा टी, और इसको इक्विवेलेंट करना है इक्वल टू -1 ऐसे लिखेंगे रिएक्टेंट्स के लिए, डिवाइड बाय स्टोइकियोमेट्रिक कोएफिशिएंट 3, यहाँ पे लिखेंगे डेल बी अपॉन डेल टी, इक्वल करेंगे। अब प्रोडक्ट्स की बारी आ रही है, सो प्लस प्रोडक्ट के केस में वो +1/4 डेल सी डिवाइड बाय डेल टी इज इक्वल टू +1/3 डेल डी डिवाइड बाय डेल टी। तो ये आपका हो गया रेट ऑफ रिएक्शन। तो एग्जाम में जो है आपके क्वेश्चन इस पे भी आ सकते हैं, बहुत ही बेसिक क्वेश्चन है लेकिन इसमें क्वेश्चन आते हैं, सो यू शुड नॉट गेट कंफ्यूज्ड कि आप जो है रेट ऑफ रिएक्शन कैसे लिखोगे। तो बच्चे में कंफ्यूज हो जाते हैं, डिवाइड ये 2 जो है इससे डिवाइड करना है या इससे मल्टीप्लाई करना है। तो आपको हमेशा याद रखना है, जब भी आप रेट ऑफ रिएक्शन लिखोगे तो उसमें जो स्टोइकियोमेट्रिक कोएफिशिएंट हमेशा डिवाइड करना है, और रिएक्टेंट के केस में माइनस आएगा क्योंकि रिएक्टेंट जो है वो टाइम के साथ डिक्रीज होते हैं और प्रोडक्ट जो है वो टाइम के साथ इंक्रीज होते जाते हैं। तो प्रोडक्ट्स केस में हमेशा पॉजिटिव आएगा, रिएक्टेंट केस में आपको हमेशा नेगेटिव साइन रखना, और हमेशा याद रखना आपको कि आपको स्टोइकियोमेट्रिक कोएफिशिएंट से डिवाइड करना हर जगह। तो दिस थिंग इट शुड बी क्लियर इन योर माइंड कि आपको कैसे लिखना है रेट का एक्सप्रेशन। तो नाउ आई एम गिविंग यू अनदर एग्जांपल। फॉर एग्जांपल आपको मैं दे रहा हूँ 3x + y, लेट्स सपोज इट्स गिवन 2z। तो अब मैं आपको बोल रहा हूँ, आई एम सेइंग राइट नाउ यू राइट द रेट ऑफ दिस रिएक्शन, एवरेज रेट ऑफ रिएक्शन। कैन यू राइट इट, एवरेज रेट ऑफ रिएक्शन। यू कैन टेक अ पॉज एंड यू कैन राइट इट योरसेल्फ, पॉज द वीडियो एंड देन यू कैन राइट इट। सो आई एम गिविंग यू सम टाइम, यू राइट इट। कर लिया आपने? सो नाउ आई कैन डू इट, आई विल डू इट नाउ। -1/3 again minus, because for the reactant x divided by 3 stoichiometric quotient, del x, let's change the concentration, divided by delta t is equal to -1 divided by 1 because stoichiometric quotient is 1, del y upon del t is equal to +1 divided by 2 del z upon del t. Now for these two reactions, like I have written the rate of this average rate of reaction, so you can see here the minus sign. Now somebody will ask this question, very interesting question, why this minus sign for the reactants and not for the products? So you can see because reactants, like this term here del A will be negative, like because change the concentration of reactant. So initially let's suppose you have some 10 moles of A, then after some time it will go like it is only 8 left because the 2 moles of A has reacted. So what will change the concentration of A? Let's suppose this reactant is A. So it will be final minus initial 8 minus 10. It will be -2. So change the concentration. So this minus here will be here. So when you have this minus sign, then only this because the rate of reaction will always be a positive quantity. It will always be a positive quantity, you should remember it. So that's why we have this minus sign here. We always take minus sign in the reactants and not with the product, because the product will start increasing with time. So the change concentration will always be positive. So that's why we have to take care of this plus and minus sign as far as the rate of reaction is concerned. So now I will give you some equation. So I will give you some reaction. Let's suppose you have to write the rate of reaction. So I will see how we can write. I hope the things are clear till now. So now I will give you some reaction. Let's suppose I am giving the reaction 4NH3 plus 5 times O2. It's giving you 4NO plus 6 times water. This is some reaction happening. You can see this is balance 4N, 10, this 6 plus 4, 10. So it's balanced. So now you can write the rate of reaction all over. That's the average rate of reaction. It will be minus 1 divided by 4, the stoichiometric quotient. Now it will be here del NH3 divided by delta T is equal to minus 1 divided by 5 del O2 divided by delta T. Now this will be equal to plus 1 by 4 del NO divided by delta T is equal to plus 1 by 6 del NO divided by delta T. Now this will be your rate of reaction. That's average rate of reaction. Till now we are discussing only the average rate of reaction. So average rate of reaction minus 1 divided by stoichiometric 4, change the concentration of this NH3 divided by delta T is equal to minus 1 divided by 5, change the concentration delta O2 divided by delta T plus 1 divided by the stoichiometric quotient 4, change the concentration del NO2 del NO divided by delta T plus 1 by 6 del NO by delta T. I hope this thing is clear to you. So this is how you can write actually the rate of reaction. So now we will see what is the instantaneous rate of reaction. Instantaneous rate of reaction क्या होता है, थोड़ा सा उसको हम देख लेंगे. उसमें ज़्यादा नहीं है, थोड़ा सा है आपका instantaneous rate of reaction. तो instantaneous rate of reaction क्या होता है आपका, जब आपका जो टाइम पीरियड है, टाइम इंटरवल becomes very small. टाइम इंटरवल जो आपका वो बहुत छोटा हो जाएगा instantaneous rate of reaction. तो डायरेक्टली वी कैन से डेल्टा टी इज अप्रोचिंग जीरो. डेल्टा टी जो है आपको अप्रोच कर रहा है जीरो को. तो उस केस में हम क्या करते हैं कि जो डेल है उसको हम रिप्लेस करते हैं डी से, डिफरेंशियल डी से. तो उसमें हम इंस्टेंटेनियस रेट ऑफ रिएक्शन जब लिखते हैं तो इंस्टेंटेनियस रेट ऑफ रिएक्शन, लेट्स सपोज हमारे पास सेम रिएक्शन है 2A plus 3B use 4C plus 3D सम रिएक्शन. तो इसका इंस्टेंटेनियस रेट ऑफ रिएक्शन कैसे लिख सकते हो आप? वो आप लिखोगे ऐसे -1 divided by 2 dA divided by dt is equal to -1 divided by 3 dB divided by dt is equal to plus 1 divided by 4 dC divided by dt is equal to plus 1 divided by 3 dd divided by dt. So this is your instantaneous rate of reaction. So the only thing that changes, like you have this time interval is very small, so we have to delta t tends to 0, so this del is replaced by d, this differential d, that's -1 by 2, the stoichiometric coefficient dA by dt is equal to -1 by 3 dV by dt is equal to plus 1 by 4 dC by dt is equal to plus 1 by 3 dd by dt. I hope those things clear to you. So now we'll do some numerical. One thing that I forgot to tell you is that, like in this case, in the rate of like the this rate of reaction, you also have two terms, like for the reaction 2A plus 3B gives 4C plus 3D, let's suppose. So you will have a term called as rate of appearance. Rate of appearance. So it's also called as rate of formation. You should not get confused. Sometimes we call it formation because products will always form until they appear. So rate of formation, rate of appearance is set. So like these products will form, that C and D will form. So now we say the rate of appearance, that's we call this ROA. RO, rate of appearance of A, is equal to, how we write it? Like we see del A, C will form, rate of appearance of C. Del C upon del T, so we put a mod here. In order to take care of sign, that's plus or minus, because we always want this to be positive. So that's why we put a mod here. Although there is no confusion as far as the sign is concerned, because if you see like 2 moles of C is appearing, 2 moles of D is appearing, so there is no plus or minus, because, or you can say 2 moles of A are disappearing, or 3 moles of B are disappearing. So it's not like minus 2 moles or plus 2 moles are disappearing. So it's always a quantity. So there's nothing like sign, but you should always put this mod here so that it will take care of the sign. Or you can see like the rate of appearance of D is equal to del D divided by del T. Now similarly you have rate of disappearance. Rate of disappearance. Now rate of disappearance you write like ROD, rate of disappearance of D. Sorry, D will not disappear, we'll have A will actually disappear. So A, like you take mod del of A divided by delta T. And similarly you have ROD of B, rate of disappearance of B, del of B divided by delta T. So in case of rate of disappearance and rate of appearance, you have to keep one thing in mind, is that you don't have to divide by the stoichiometric quotient. By the stoichiometric quotient you have to divide only in case of the rate of reaction. When you are trying to write the rate of rotation expression, only in that you have to take the stoichiometric quotient and divide in case of the reactants as well as the products, but not in case of this rate of appearance and rate of disappearance. So rate of appearance you have to simply write like this: change the concentration of C divided by delta T and take the mod. Similarly, rate of disappearance will be change the concentration of the reactant A divided by delta T. So I hope this thing is clear to you. So now we try to solve some numeric. We'll apply these things there and we will see how we can solve a numeric. We'll take some numerical and try to solve it. We have a numerical here. Let's suppose we have a question is given, and so the question is I will write N2 plus 3H2 reduces to 2NH3 is the reaction. So it says during the formation of NH3, 2 moles of N2, that is nitrogen, disappear in 1 minute. Now we have to find rate of reaction. The first thing we have to find rate of reaction. Second, we have to find ROD, that's the rate of disappearance of N2. And third, we have to find rate of appearance of NH3. It has also given the volume of the vessel. The vessel in which this reaction is carried out. Volume of vessel is 1 liter. So 1 liter is the volume of the vessel in which this reaction is carried out. Now how will you solve this equation? So you can pause it and you can solve it. No, I will do it now. Now let's start. Now the first thing is what you will do is you will write rate of reaction. ROR is equal to minus 1 by 1 del N2 divided by del T is equal to minus 1 by 3 del H2 divided by del T is equal to plus 1 by 2 del NH3 divided by del T. So this is the rate of reaction. Now it's saying that during the formation of NH3, 2 moles of N2 disappear in 1 minute. So it is saying that like D N2, yeah, we can say del N2 by del T. The change in the concentration of N2 to 2 moles are disappearing. 2 moles disappear in 1 minute. So that's your time is given 1 minute. Now also the volume of the vessel is given, like concentration is like 2 moles per liter. So or we can say that 2 moles per liter per minute. This is actually your del N2 by del T. Now we have to first find the rate of reaction. Now the rate of reaction, how we can find it? It's like we have rate of reaction is minus 1 upon 1. Now del N2, you have del N2 by del T. Now del N2 by del T is like you have 2 moles, so minus 2 divided by this liter divided minute, so it's like minus 2 divided by 60. So it will be 1 moles per liter per second. So it will be minus 1 by 30 moles per liter per second. So it's minus 1 by 30. Now rate of reaction will be 1 by this, when we take it in terms of del N2, so it will be minus 1 by 1, it's del N2 by del T. So it will be minus 1 by 1 into minus 1 by 30. So it will be plus 1 by 30 moles per liter per second. This is your rate of reaction. Now you have got the rate of reaction. Now what we have to find is the rate of disappearance of N2. Now next is you want to find the rate of disappearance of N2. Now how will you find the rate of disappearance of N2? It's the rate of disappearance of N2. You will find. Now again you will write rate of reaction is equal to, in terms of N2, what is the rate of reaction? It's minus 1 by 1 del N2 by del T. The rate of reaction is given, that's plus 1 by 30 is equal to minus 1 by 1. This is del N2 by del T. Now this I will try to like this, plane this now. So here I will try to solve. Now it's given here plus 1 by 30 is equal to minus 1 by 1 del N2 by del T. So you have basically del N2 by del T is equal to minus by 30. Now what we have to find is we have to find rate of disappearance. Rate of disappearance of N2. That's what we have to find. Rate of disappearance of N2 is basically mod del N2 by del T. So when you take mod of this minus 1 by 30, minus 1 by 30 mod, it will be plus 1 by 30 moles per liter per second. This is actually the rate of disappearance. So after this, what you have to find is you have to find rate of appearance of NH3. Now after this, you have to find the rate of appearance of NH3. Now that we can also easily calculate. Rate of appearance of NH3. Rate of, again we have to write rate of reaction will be in terms of NH3 plus 1 by 2 del NH3 by del T. Now rate of reaction you know is like plus 1 by 30, because we have already calculated this rate of reaction. That's plus 1 by 30 is equal to, this is plus 1 by 2, this is gel NH3 by gel T. Now here 2, 1, 15, so we try to find gel NH3 divided by gel T is equal to plus, that's 1 by 15 moles per liter per second. Now we have to find rate of appearance, ROA of NH3 mod gel NH3 by gel T. When you take mod, so it's plus 1 by 15 moles per liter per second. That's ROA of NH3. So it's very simple to calculate these things. So del NH3 by del T rate of is 1 by 15 moles per liter per second. So now we can take one more question. To practice this more, we can take one more question. We can practice one more question. Let's do that. Let's do it very quickly now. Well, I hope now, till now, you may have got this idea. You find these things. So I will take one more question and I will try to solve it. And I hope you also will solve it yourself by pausing the video. Now the question is, some question is here like we have some reaction 2 and 245 is giving 4 and O2, some reactions happening plus O2. It says that if the rate of appearance of NO2 is 2 moles per liter per second, find पहला आपको निकालना है rate of reaction, first rate of reaction. The second thing is you have to find rate of disappearance of N2O5. Now these are the two things you have to calculate. Now let's solve it. I hope you pause the video and we try to solve it yourself. Now see what we will do. We will try to write the rate of reaction. First thing is we write rate of reaction. ROR is equal to minus 1 by 2 del N2O5 del T is equal to plus 1 by 4 del NO2 divided by del T is equal to plus 1 by 1 del O2 by del T. Now what we have to find is, first we have to find rate of reaction. Now we have been given that rate of disappearance. We have been rate of disappearance of NO2 is 2 moles per liter. So what we have given is del NO2 by del T is equal to minus 2 moles per liter per second. Sorry, this is actually rate of disappearance. So it's like your take mod. It's plus 2 moles per liter per second. And then what we'll do is like, now rate of disappearance is given. So what we have to find is, now we have to find rate of reaction. Rate of reaction is in terms of N2, it is plus 1 by 4. It is del NO2 divided by del T is equal to plus 1 by 4 into. So this is actually 2. So it will be plus 1 by 2 moles per liter per second. So your rate of reaction is 1 by 2 or plus 1 by 2 moles per liter per second, that we have found. Now after this, what we have found is, we have to find rate of disappearance. Rate of disappearance of N2O5. Now again, we know ROR is equal to, in terms of N2O5, it's plus 1 by 4, sorry, minus, in terms of N2, it's minus 1 by 2 del N2O5 divided by del T. Now R is given. What's that? It's plus 1 by 2 is equal to minus 1 by 2 del N2O5 del T. So now you have here plus 1 by 2 minus 1 by 2 cancel. So this is like del N2O5 divided by delta T is equal to minus 1. Now we have to find rate of disappearance. So we have to find ROD, rate of disappearance of N2O5. Now we have to take the mod of this, that's del N2O5 divided by delta T is equal to, so mod of minus 1 will be basically plus 1. That's plus 1 moles per liter per second. So this is basically rate of disappearance of N2O5. You have to always take the mod in order to take care of the sign. It's minus equal, the mod will make it positive. Now you can solve so many questions from the textbook, or you have reference books also available at your places. So you should try to solve as many as questions. So you practice more, so it will be better for the exams. जितना आप एग्जाम के लिए प्रैक्टिस करेंगे तो उतना आपको एग्जाम में आसानी होगी, तो आप इजीली एग्जाम में क्वेश्चन अटेम्प्ट कर सकते हैं. So you have to practice more and more. You will try to see some graphical representation. हम इसकी अब graphical representation देखते हैं. So now we will come to the graphical representation. तो graphical representation में जो है आपका, अगर आपका for example जो है reaction, आपका जो है reactant होगा. Let's suppose you have the reactant. You have the reactant. And its versus time. Yeah. तो reactant के केस में आपका क्या होगा? तो it will start decreasing like this. तो reactant की concentrated time के साथ decrease करेगी. और अगर आपका product होगा, let's suppose this is the product here. With respect to time, product will start increasing like this. So because it will start from the zero, initially the product will be zero, so it will start increasing like this. So this will be the graph. Now for example, you have some reactant A. You have some reactant A which is taking part in the reaction. You have some reactant A. Let's suppose it's like this. आपके पास एक reactant A है और ग्राफ खींचा है respect to. तो let's suppose आपका जो ग्राफ आ रहा है वो कुछ इस टाइप से आ रहा है. So what we'll do, you will try to take a tangent here and you will draw some tangent. You will draw a tangent here. Now it makes some angle here with this. Now what you write is like you write slope. What slope is tan theta. That's tan theta. That's what's called a slope. Or it will be like dA by dt. Now what you have to do is you have to take the angle with the x-axis. That's this angle. That this angle will be 180 minus theta. You have to always take this tan of this angle, 180 minus theta. Now, for example, we have some reactant. This was for the reactant. Now we have some product. Let's see with respect to time. Now it's like the reactant is increasing like this. Now what you do is like you draw some tangent here. You draw some tangent here. We have made tangent डाला. At this point we are drawing some tangent. It is making some angle here, theta. Now again you try to find the slope. Slope is tan theta is equal to dc by dt. So that actually will, this slope actually will give you the rate constant. So that's basically give you the rate of reaction, sorry. It will give the rate of, this is basically your graphical representation, for example here. Tan theta is always the slope. So this dA by dt is basically the change the concentration with respect to time. So now we take some question. For example, we have some question here. The question. Let's suppose we have a question here. So I did this question, which actually is based on the slope concept. Question is here like we have N2 plus 3H2, it is giving you 2NH3. Now what we do is like we have some graph here. And this is like we have some H2 concentration here. And here we have time on this x-axis. Now this is like some curve here. So this here we have, at this point we have 10. At the other point, let's suppose we have 6. The corresponding times actually are 2, and this is 4. Now here you can write rate of reaction. Simply it's equal to minus, it should be now clear to you, minus 1 by 1, like d n2 by dt is equal to minus 1 by 3 d h2 by dt, and it's plus 1 by 2 d nh3 by dt. Now it should be clear to you. Now you should be able to easily write this rate of reaction. Now what we have to find is like we have to find the slope. Now you know that slope is equal to tan theta is equal, but we don't have any angle given here. But we also know slope is like y2 minus y1 divided by x2 minus x1. Now y2 is like, this is like your initial time, this is your final time. Now final, this y2 is final, that's 4. Corresponding to 4 we have this concentration 6. So we write 6 minus 10, divided we have 4 minus 2. So it's minus 4 divided by 2, so it's minus 2 moles per liter per second. So this is actually a concentration, the slope, rate of reaction. Now we have to find here, like you actually found this tan theta, that's the dH2 by dt. Now we have to find the rate of reaction. Rate of reaction, you can write it in terms of H2, it's minus 1 by 3 dH2 by dt. It's minus 1 by 3 into, it's minus 2, so it's 2 by 3 moles per liter per second. Now in terms of N, which is N2, now we have to find rate of disappearance of N2. Two things you have to find rate of disappearance of N2. Now I will try to drop this here. Now we have to find rate of disappearance of N2. Rate of disappearance of N2. Now we know ROR is equal in terms of N2, it's what, minus 1 upon 1 dN2 by dt. The ROR we have found here is what, it's 2 by 3 is equal to minus dN2 by dt. So that means dN2 by dt is equal to minus 2 by 3. So what we have to find? We have to find rate of disappearance of N2. So N2 will disappear, it will be equal to, the rate of disappearance of N2 will be equal to mod of this dN2 by dt. So mod of, basically it will be mod of minus 2 by 3, that's mod of minus 2 by 3 to the plus 2 by 3, and units will be moles per liter per second. So 2 by 3 moles per liter per second. Now another question that's related to graphs, very important question, we try to solve it. I hope you solve more questions at home and you try to pause it and see if you are able to solve these questions. Another question what we'll take is like, what is the question is basically 2p plus 3q, some relation is happening, it gives you some like product R. Now you have to find, first you have to find ROR, second is you have to find rate of disappearance of R, ROA, of R, because R will start appearing. and you have been given this graph here. That's the concentration of Q, that's in moles per liter, and here on this axis you have time in seconds. So your graph like this. Now this angle is 45 degree. This will be 180 degree minus 45 degree. So now you have solved this. Now here what we'll do is we will write slope is equal to tan theta. Now but this theta you have to take this, which it will make this x-axis. So it will be tan 180 minus 45, it will be minus tan 45 degree, it will be minus 1. So slope will be minus 1. Now you will find rate of reaction. Rate of reaction will be equal, but slope basically is dq upon dt. That's basically your slope. Now rate of reaction in terms of it will be, we will write general, that's minus 1 by 2 dp upon dt is equal to minus 1 by 3 dq upon dt. It will be plus 1 by 1 dr upon dt. Now rate of reaction will be equal to, in terms of q, it's minus 1 by 3 dq upon dt, which is basically minus 1 by 3 into minus 1, because minus 1 is slope, so minus plus, so it will be 1 by 3 moles per liter per second. This is your rate of reaction. When we find it, so rate of reaction 1 by 3 moles per liter per second, then you have to find rate of appearance of A. So again, rate of reaction will be equal to, or in terms of or it will be what, plus 1 by 1 dr by dt. Rate of reaction is 1 by 3 is equal to plus 1 by 1 simply dr by dt. So your dr by dt is basically plus 1 by 3. Now we have to find rate of appearance of R. Now rate of appearance of R. Rate of appearance of R will be equal to mod of d R by dt. So mod of this, it will be simply plus 1 by 3 moles per liter per second. So that will be your answer in this case. Now we have one more question. Is again we will have one more question simply based on the graphs. So you find such questions in the entrance examination. So these questions you should try to do at your places. Find from these reference books or textbooks. So you find questions like these. They are very important. But again, the question is here, like you have 2a plus 3b. It gives you, 2a plus b gives you 3c. Now you have to find, the first thing you have to find is rate of reaction at 5 seconds. Also find a at 5 seconds. But these two things you have to find. But you have been given the graph. This graph you have been given. That's the graph is given like concentration of B, and here it's time. Now this graph is given, you have been given like this. Now at time 5 seconds, like this your time 5 seconds. Like this, here at time 5 seconds. So you draw some slope here, you make here, and you make this angle that's 30 degree. So this will be 180 degree minus 30. So again, you will try to find here the slope. Very easy question. Slope is equal to tan theta is equal to dp by dt is equal to tan 180 minus 30 minus tan 30 minus 1 by under root of 3. So now we got this slope. Now what you have to find is ROR, rate of reaction at 5 seconds. Now ROR, rate of reaction will be simply minus 1 by 2 dA by dt is equal to minus 1 by 1 dV by dt is equal to plus 1 by 3 dC by dt. So now we have to find in terms of this dV by dt. So ROR will be equal to minus 1 by 1 dV by dt. It's minus 1 by under root 3. So it will be simply plus 1 by under root 3 moles per liter per second. So rate of reaction we have find 1 by under root of 3. Now we have to find rate, also find A, that is rate of appearance. Sorry, rate of disappearance of A. We have to find rate of disappearance of A. This is basically a rate of disappearance of A. That's what we have to find. Now rate of reaction we have found is plus 1 by under root of 3. Now how we can find rate of disappearance? Again we know ROR is equal to minus 1 by 2, that's dA by dt. Now ROR is plus 1 by under root of 3 is equal to minus 1 by 2 dA by dt. And from here you can simply find dA by dt is equal to minus 2 by under root of 3. And when you have find rate of disappearance of A, just simple mod of dA by dt is equal to mod of this. So it's mod of minus 2 by under root of 3, simply plus 2 by under root of 3, and units are in moles per liter per second. So you have found the rate of disappearance of A at time, that's 5 seconds. So this question was very easy. I think if you have got the concepts like how you find this slope, that's tan theta, so then the questions are very easy. Then you have just apply the concept of rate of reaction or even rate of disappearance or rate of appearance. So these things become very easy. I hope you enjoyed today's lecture. So I'll be coming with more lectures and maybe good lectures, and I wish you all the best and keep studying. Thank you.